Welcome back to the physics class. This is Ramesh. Now we are entering the new chapter, dual nature of radiation and matter. Do you know about the particles? Particles means what? Grains of sands, marbles, electrons, protons. These are all particles. What are the properties of particles? Particles having mass, charge, energy, momentum. So particles have some properties. It has mass, certain mass, that is a tiny concentration of matter. So it has small, very small negligible masses. Okay. For example, electron having mass, proton having mass. Okay. Charge. It has charge. It has energy. It carries momentum. Everything is there. Okay. This is what particles. Okay, good. What is wave? Wave is a broad distribution of energy. That means it carries momentum, energy, but it doesn't have mass or charge. It is a broad distribution of energy. That is wave. Okay, so I just give an explanation about particle and wave. What is the need of it? The need is, what is the nature of electromagnetic radiation? That is the question here. Light is visible light. Light is an electromagnetic wave. We know very well light is an electromagnetic wave. Okay. It obeys what? In the electromagnetic radiation, the light obeys interference, diffraction, polarization. The concept of polarization proves light is transverse in nature. So the electromagnetic radiation propagates with the speed of light. So that property proves light is one of the member of the electromagnetic spectrum. Okay, we know very well. It obeys interference, diffraction, polarization. In these cases, these electromagnetic radiations, that means light, propagates in the form of waves. What type of waves? Transverse waves. We know very well about waves. Example for waves is light wave, sound wave, ripples formed in the water, pond, etc. So light is in the form of wave in the case of interference, diffraction, polarization. Okay. But in the case of photoelectric effect, black body radiation, for such cases, light is in the stream of particles, not the waves. If we consider light is only the wave, we can't explain the photoelectric effect successfully. We can't explain the black body radiation. So in that concepts, light should be a stream of particles. So here one question arises. So what is the nature of light here? Is it a wave or is it a particle? It is neither a wave nor a particle. It has duality. Sometimes in some phenomena like interference, diffraction, polarization, it behaves like a wave. In some phenomena like photoelectric effect, black body radiation, it is considered to be a stream of particles. So light is neither a particle nor a wave. It has duality, dual nature. Sometimes it behaves like a wave, sometimes it behaves like a particle. Light is not a perfect wave, light is not a perfect particle all the times. Okay, that it has dual nature. That is the intro of this lesson. In this chapter, dual nature of radiation. So radiation has dual nature. One is wave, another one is particle. Okay, this is about the intro of this chapter. So we learnt from these, light has dual nature. Okay, good. Then what is the next topic we are going to discuss now? That is electron emission. Electron emission. What is electron emission? Where it takes place? It takes place on any metal surface. Any metal surface. What is electron emission? Consider a metal or a conductor which consists of a conductor like a metal. It consists of large number of free electrons. Large number of free electrons. These free electrons are moving randomly, we know very well, it we studied in the current electricity chapter also. Okay, in a conductor, what is the quality of the conductor? The main quality of the conductor, it consists of large, very large number of free electrons. So consider a conductor, consider metal which consists of large number of free electrons which are randomly moving. That means it has some kinetic energy to move. Why these electrons are moving? Because these electrons are present in the, this is what nucleus, this is positive charge. For example, these are free electrons. These electrons are present in the outermost shell of the atom. So outermost shell, because these are present in the outermost shell, the influence of the nucleus is very less. So the electrons are able to move freely. So these electrons are called as free electrons. So these electrons are moving randomly inside the conductor, inside the metal surface, but it can't leave the surface. It can able to move freely. It has some kinetic energy, but that kinetic energy is not enough to remove the electron from the metal surface. So electrons are moving. How it is moving? Randomly moving. This kinetic energy is able to remove the electron from the metal surface? No, it is not enough. Okay. What is the factor which binds the electron with the nucleus? That is called potential barrier. The potential barrier, the barrier given by the influence of the nucleus, which opposes the electron which leaves from the surface, is called potential barrier. The barrier which is given by whom? Nucleus. Which is given by the nucleus to the electron, which prevents the leakage of electron from the metal surface, which prevent to escape the electrons from the metal surface. That type of barrier is given by whom? Nucleus. That barrier is called as potential barrier. If the electron want to escape from the metal surface, means we can give some external energy. Otherwise the electrons can't escape from the metal surface by itself because of the potential barrier given by the nucleus, positively charged nucleus. The attractive pull given by the positively charged nucleus, that is the potential barrier here. If we are giving any external energy, then the electron acquires this energy, then the electron can escape from the metal surface. Then the electrons are emitted from the metal surface. The emission of electrons from any surface of the metal is called as electron emission. Once again I tell you, the emission of electrons from any surface of the metal is said to be electron emission. Okay, if you want to remove the electron from the metal surface, we must give external energy. Otherwise the electrons are randomly oriented inside the metal, not escaping from the metal surface. Okay. Then next concept is here. I am going to tell you one important thing, that is what? The minimum energy required to remove the electron from the metal surface is known as what? Electrons already having kinetic energy, but it is not enough to remove. So the minimum energy required to remove the electron from the metal surface is known as work function of the metal. Don't forget, this is an important term in physics. Work function, that is indicated by the letter pi naught. Pi naught is the work function of a metal which is nothing but, which is defined as the minimum energy required to remove an electron from the metal surface. That is known as work function. Okay, so if we are applying the work function externally, then the electron can be removed from the metal surface. There is no doubt. Okay, consider a situation. I want to tell you a situation. If the free electrons having the kinetic energy of 0.5 electron volt, for example, What is electron volt? I will tell you, don't worry. The minimum kinetic energy, the kinetic energy of the free electrons inside the metal is 0.5 electron volt. Okay. But the total energy to remove the electron from the metal surface is, for example, 3 electron volt. If we are applying 3 electron volt, the electron will remove from the metal surface. Okay, but the electrons already having the kinetic energy 0.5 electron volt. Then how much energy is needed to remove the electron from the metal surface? Electrons already having how much? 0.5 electron volt. If the electron want to escape from the metal surface, the total energy needed is 3 electron volt. That is not work function. The total energy. Okay, now the electron needed how much energy? That is called work function. That is how much means 3 minus 3 electron volt minus 0.5 electron volt. That is 2.5 electron volt is the work function of the metal. 2.5 electron volt is needed. Here 2.5 electron volt is the work function of the metal which is needed, which is the minimum energy needed to remove the electron from the metal surface. Is this work function is constant for every metal? No, exactly no. This is not a constant for each and every metal. For every metal, the value of work function is different. That means work function is different for different metals. It is not constant for all the metals. For the phenomenon of photoelectric effect, we have to choose low work function metal, because low work function metal needed very less energy to remove the electron from the metal surface. So for example, low work function is cesium. It's low work function. It can be able to liberate an electron from the metal surface very easily, because it requires very less amount of energy, because its work function is, because that cesium work function is very low. Okay, that is about work function. The next I want to tell you one thing. What is electron volt? We know very well the SI unit of energy, the minimum energy I tell you. So the SI unit of energy is what? Joule. Then what is the unit of work done? Joule. Why you are writing here EV? EV is electron volt. What is electron volt? How to relate joule and electron volt? One electron volt is nothing but 1 electron volt. Define 1 electron volt. 1 electron volt is the kinetic energy gained by the electron when it is accelerated through a potential difference of 1 volt. Once again I will tell you, 1 electron volt is the kinetic energy gained or acquired by the electron when it is accelerated through a potential difference of 1 volt. Okay, then how we define 1 electron volt? 1 electron volt is the kinetic energy gained by the electron. Okay, that means what? Work done by the electron. That is work done. Energy is otherwise known as work done. Work done, the formula for work done is work done by the electron. Kinetic energy gained by the electron is otherwise known as work done by the electron. That will be equal to W equal to V into Q. Here Q is the charge. Where charge of the what? Charge of the electron. Electron charge is how much? 1.6 into 10 power minus 19 coulomb into volt. How much volt it is accelerated? 1 volt. So coulomb into volt, which gives joule. 1.6 into 10 to the power minus 19 joule. So 1 electron volt. The relationship between electron volt and joule is this. 1 electron volt is nothing but, which is equal to 1.6 into 10 power minus 19 joule. That is the relationship which we will use for solving the problems. Okay. In this class we learnt about what? We discussed about what? I will give the intro about dual nature of radiation. Light having dual nature. Sometimes it behaves like a wave, sometimes it behaves like a particle. It is neither a particle nor a wave. Okay. Then we are discussed about electron emission. How the free electrons are present inside the metal surface, how they are moving. They are moving randomly. They have kinetic energy, but that is not enough to escape from the metal surface. Okay, so I tell you about potential barrier, electron emission, and also the main thing is work function. What is work function and how it is denoted? What is the unit of work function? How the unit of work function is related with the SI unit joule? All these things we discussed in this class. If you want the electron emission, if you want the photoelectric emission easily or electron emission, we have to use low work function materials selectively. All the materials does not having the same work function. Okay. So these are the things we discussed in this class. These are the things we are now discussed. In the next class we are going to discuss about what are the type of electron emission: thermionic emission, secondary emission, photoelectric emission. So there are lot of types, but we are focusing only on one type, that is thermionic emission, which we are going to discuss in the next lecture. Okay, till that, bye my friends, bye my dear students. You please watch this, it will be very useful for you. Okay, thank you my dear students, bye.